Raul just showed us a lot about what we're seeing happening to Lotus as a process. And a lot of what motivates that is that there are new capabilities that we want to add around making the value of a Filecoin miner better in terms of enabling this retrieval market. And one of those is indexing. And so what we're meaning when we say indexing is that it's sort of important for a miner to know what content it has and to be able to get that content back out. So right now, content is stored in Filecoin in pieces and deals. And so these are, an 8 gig or a 32 gig car. It's a bunch of individual SID data items. And we refer to it based on that hash of that overall thing. And so what is hard to know is which individual SIDs, which pieces of content are inside of those things, and to map those individual pieces of content that someone may want later back to which miner has it and which piece, which archive is that individual piece of item in, or that individual piece of content. So this problem of like content routing from a SID into the entity that has that is sort of what IPFS is already solving, right? And is the content routing problem. But one of the things that we think is sort of the useful next step to enabling this in the context of the Filecoin network is we want to have some interaction between an index or some external node that is going to help us with content routing and the miners, the nodes that have content. And we think that this extension where we have this interaction and interface that we define for a node with content that sort of accumulates new content and is going to notify that, and then some external party that can learn what that index and what the available content is one that both isn't and doesn't need to be specific to Filecoin. So we can make this interface more general so that existing services that have a lot of content address data maybe also fit the same model of they, in some sort of checkpointed way, will get more content that they want to make available in a content address network setting. And that interface probably looks pretty similar to what a miner's lifecycle looks like of content sort of coming and going in batches. So we've got two sides of this sort of interface interaction that we need to think about. We need to think about what that means that we're going to ask on the miner side. And then what is this sort of index process that then flows up to clients. And the client that we're thinking about here specifically are like, how do we make this content available to IPFS clients and sort of available more generally in a useful low latency manner. So enabling this CDN style use case. So this is starting to dive deeper into what the indexing process. Can I make this smaller for you guys? Probably. There's a little bit smaller. Really doesn't want to make that sidebar smaller, but we'll live. So we're imagining that there is some sort of indexing service that's going to live on a miner, and that as the market completes a deal, that probably is a trigger that triggers the indexing service to make that new content available. What does the indexing service need to do? Well, it needs to generate an index. One of the, and so what is an index? Well, at some level, it's just like the list of all of the SIDs that are in that deal. And so we have tools that can go over a car archive as a deal is currently stored. We could imagine with a different proof of replication that potentially that storage is different, but it is still a bunch of content addressable pieces that are referenced by SIDs. One of the things that I think we're still trying to fully understand is whether that complete index of all of the SIDs that are contained in a piece is the thing that we want to have as the interface. So if an indexer or if the rest of the network wants to say, hey, what content do you have? Is the answer really that list of SIDs? And so the motivating example here is that a lot of data that we have is in Unix FS format. And UnixFS format has two things that are sort of interesting. One is that if you've got a large file, that file is spread across multiple items, right? So individual blocks of data are limited in size. And so when you have a large contiguous sort of file that's more than a few megs, what you end up with is individual blocks and then a metadata file that sort of points to all of those blocks. And so the question is it useful for the miner to just give its undifferentiated list of SIDs? Or would it be more useful to only have the SIDs of the files themselves rather than their individual pieces? Or is there something else that we need to give in terms of this index, like the DAG structure of it? So this SID links to these other SIDs. Or is there something else beyond that that we need even, so that an indexer can actually do a useful job of understanding which things it needs to prioritize? And so right now, what we're imagining is there's probably some baseline of just the undifferentiated list of SIDs. That may turn out to be too big. And so we may ask the miner who knows this structure or can have some heuristics to also be able to provide alternative lists or sublists, like a semantic index of the list of files in case it's UnixFS, or if there's other data formats that we find to be commonly used that are valuable to do that, where you do need to know some semantics about the actual data in order to do an efficient pruning. Perhaps that needs to live on the miner, because it's unclear if either the SID or the DAG of SIDs, that there's a good balance that can be provided at this interface that lets an indexer node do useful subselection just on that list, that it may need to be done someplace that has the data, which would be the miner. Okay, so you've got some service that now has this list of data. How do you get that data to an indexing node that's then going to do the work of generating an overall index and being able to say, oh, this SID, that's on this miner? And probably what that looks like is two pieces. There's a send advisory of new data available. So whenever a new deal finishes or there's a new chunk of data items that have become available on the miner, it'll publish probably on, and this can work just sort of as a gossip sub topic that we agree upon, that there's a message with a new root, a new amount, a new list of SIDs that are become available. And that will trigger indexers who are watching that miner to then go and pull that set of SIDs from them. And we can imagine that pull happening over an IPFS-like thing where these are all IPLV data. And so there's a new SID that gets put out and the indexers fetch that SID with a connection to the miner and get back, or a connection to this index process that maybe exports itself over IPFS and gets back the list of new SIDs that need to be indexed. And so we started writing up that interface a little bit in terms of how we think about these. So what is the advertisement that happens over PubSub? And so you have your a SID that points to sort of a manifest of this new list of data that exists, and along with the previous one, and along with sort of how to connect to you, and then you sign it. And this means that miners sort of get one global view of what content they are making available for indexing, and that helps them that helps us to sort of have this consistent view that we are able to enforce and make sure that miners, if they advertise data as available, they have to advertise it as available to everyone. And so that's sort of one step where once we have those semantics, we can make sure that there's sort of the availability of a open marketplace that you don't have, at least through this process, miners that claim to they'll only make their data available to their partnering CDN. That rather any indexer node would be able to find miners and see and validate the same index, basically. Okay, so this hopefully starts to sound like a plausible interface of something that we might ask about as a way to now have these lists of what content is available. And we could imagine aggregating that. And I've sort of been purposefully vague about what an indexer node actually is doing, and whether an indexer node is is even like a single logical entity, or whether this is multiple decentralized ones or sharded. Likely, the first version is we make something that is logically centralized, and we wait for that to fail over in terms of its ability to scale, and then we figure out how to shard it as a way to get to an MVP. And you could also imagine that there's multiple of these that different people run as a secondary thing. Okay, but then there's also the subsequent question of the second side of this interface, which is you've got these indexer nodes now that have these big indexes of a lot of SIDs that are available within Filecoin, and which miners and which pieces they reside in. And we still now have the problem of, okay, you've got a bunch of clients that want to do that lookup of, I've got a SID and I would like to know who has it. And this is a problem that IPFS already solves via a API called content routing. And what that actually looks like right now is the method find provider, where you give a SID and you get back a peer's address info. So you learn which peer has that content. And this is the interface that currently is exported by the DHT and by other content routing modules within IPFS. So the relevant thing here is that what we actually probably want to return is not just a peer address info, but something that's a little bit more extensible, that we can do things like provide a record that says, well, this miner has this data, and also is, there's some other metadata that we start to really care about here. Like, this is stored in Filecoin. And so, there's probably some other protocol like Go Data Transfer that you might need to use to get to it, rather than just starting Bitswap and trying to get that SID. And also maybe, it's in this piece, there's some other metadata that's maybe relevant so that the miner can efficiently get it for you. And these start to look a lot like the smart records that Petar described to us yesterday, which is what we want to be able to have in terms of the shape that we get back is not simply a peer, but a record that is this sort of extensible view of what we know about this SID, right? Because the record that I get back is actually likely to have multiple miners that are multiple options of miners that all have that piece. And so you've got multiple miner piece records, and then you've got some extensibility of the protocol where you're able to say, and you should get to it via this thing. There's a bunch of interop sort of path of least resistance that's still getting figured out in terms of how do we enable that actual subsequent fetch of, okay, so an IPFS node gets this record from an indexer node potentially, and then how does it know to actually get the data out of a miner? And that there's sort of a few different ways, and we'll see how hard they end up being relative to each other. With the current GraphSync Go Data Transfer process that exists in the market part of Filecoin miners, the process is happens in a few steps, where first you on-chain do a retrieval deal and ask for that data. And then that results in a voucher, and you use that voucher to then initiate the Go Data Transfer session over which you transfer the data. For some subset of the data that's stored, it may be possible to incentivize miners to allow for free retrieval deals. And so one thing you could imagine trying to say here is that in this extensible protocol thing, you can say, hey, the protocol you should use is data transfer, and it's okay, you can pass in just sort of an empty voucher here, and just go straight ahead to data transfer and see if it works. And for miners that allow free deals, that may be sufficient. And so you may be able to do this without popping back up. Once it is a paid deal, then you need to do this Filecoin specific process next of actually paying for it, or delegating to someone else, like your content provider, the app, the DApp or something that's going to be willing to pay for it. And that starts to get somewhat specific. And so we need to think about how we allow that to get bubbled up in an IPFS client so that it can delegate out to, a Lotus plugin that can make the deal and provide a way to allow for extensible protocol handlers at the IPFS level. But if we have some point of extensibility, both in what records look like, and then also on protocols where if you don't have it built into IPFS, there's a place to plug in on the client. We think we can get from record and from this different interface of finding providers to getting the data and making it available on gateways, on Go IPFS nodes, on embedded nodes, and in a bunch of people who want sits. The other thing that we're going to have to figure out is how does the IPFS node know that it is getting or ask an indexer node. So if we start with a limited number of these indexer nodes initially, what does this initial arrow look like where we find the right indexer nodes and make use of them? And that also likely goes through a few iterations. We could imagine that you can do sort of an initial delegated content routing. This is something that JavaScript IPFS nodes already do, where they delegate their find provider request over to a companion Go node that they know. But you could imagine writing that same implementation of content routing in Go IPFS, so that, for instance, if there is a known indexer, the gateway could just delegate to an indexer that gets stuck very close to it, so that it's low latency. So that's one option. And in an initial version, you could also imagine that the thing that happens afterwards, as you begin to decentralize this, is you have an advertisement of indexers. So indexing services can announce or provide themselves as a service provider of indexing, and then nodes keep track of who they've seen as potential indexers and keep track of how fast and how reliable these indexers are, and use that as a way of prioritizing who they ask for indexing queries. So that there is, I think, naturally going to be a market for this indexing, which is you want an indexer who is close to you, and you want and there's a trade-off within the indexing of, are you going to prune down to a smaller index of head queries of popular sits that are getting asked for a lot, where you can respond to 80% of the queries in relatively small number of milliseconds? Or are you going to keep the much larger list of all possible sits so that you can answer the longer tail of sort of rarer queries, which will be a more expensive lookup and higher latency? So there's a couple of places of potential differentiation there in indexing. I think we also still need to figure out what is the story going to be that these indexing nodes get remunerated directly in this protocol. There's two places there that you could imagine that retrieval mining indexing playing into the overall economic game. One is that a client could potentially pay somehow, or just based on usage of number of queries, that could go into the network somehow, allocating resources to the indexing nodes. The other one is that for deals that are made off of an index poll to the indexer could get some small commission on those, so that it goes within the existing sort of payment channel thing. But basically, there's like a finder's fee type thing where the indexer node that did help make that deal happen gets somehow tags in the record that it returns, so that when the miner does its payment channel thing, the miner sort of tips the indexer for bringing it in the traffic to complete that sort
quick
of
time check.
Yep.
What, can you wrap it in 1 minute?
Yeah, I think I'm basically done talking about these two protocols. This is sort of a bit more future looking. We're just, I think, it gives you a sense of what the hopefully sort of first concrete steps look like in terms of getting to something that works, and then a bunch of the things we're imagining. But we would like feedback, certainly, in terms of other constraints we need to be thinking about, and other ways that you all in particular are imagining plugging in or would have to interact with this, or things that sound unrealistic. So there is a breakout session in about, I don't know, an hour, something like that, where I'm happy to talk with you all more about details of what actually will happen here. And with that, I will turn it over to Hannah.